Okay, good morning, everyone. Today we're going to continue on in our exploration of rational expressions. Today we'll be looking at solving rational equations. Solving equations involving fractions, but our fractions will have polynomials. So before I actually get into solving rational equations, let's just work with solving fractions that involve x. We're solving for x. So here I want you to notice here I have 2x over 5 plus 7 over 2 equals 3x over 4. What makes this somewhat difficult is the fact that we have a fraction or fractions, and we want to solve for x. A little difficult to solve for. So what we can do, we can multiply the entire equation by the least common denominator. And my LCD, or least common multiple, has to include the 5 and the 4. Okay, so my LCD will equal 5 times 4 equals 20. So if I multiply my entire equation by my least common denominator, which is 20, and so I need to distribute the 20 to each term here, you'll see we'll get rid of the fraction. So I have 20 times 2x over 5 plus 20 times 7 over 2 equals 20 times 3x over 4. So what I'll do is I'll divide and then multiply, and you'll see I'll get rid of the denominator. So I have 20 divided by 5 is 4, and 4 times 2x is 8x. Plus, and then I have 20 divided by 2 is 10, and then 10 times 7 is 70. And then finally, I have 20 divided by 4 is 5, and 5 times 3x is 15x. And see, now you'll see that this equation here, since I've gotten rid of my denominator, is a lot easier to solve than the equation I initially started with that had all fractions. Okay, that's easier to solve. So now I can subtract 8x, and I'll get 70 equals 7x, and then 10 is equal to x. Okay, so the plan of attack here, as I recall my teacher used to saying in math, if you have the fraction blues in algebra, you can get rid of them. Multiply by the LCD. So to solve rational equations, we start by multiplying each term of the equation by the least common denominator of all the expressions. In this, we'll eliminate the denominator of the rational expression. So here we have an example. And I like to write everything as a fraction. So I have x over 1 minus 18 over x equals 3 over 1. So I want to get rid of my denominator. So I see my LCD has to have the 1 and the x. So I am going to multiply my entire equation by my LCD, which is just x. 1 times x is x. And then I'll divide and multiply. So x divided by 1 is x times x gives me x squared. Minus x divided by x is 1 times 18 gives me 18. Equals, and then x divided by 1 is x times 3, and that will give me 3x. Oops, that will give me 3x. Okay, which is what we got here. X squared minus 18 equals 3x. And so now, if I subtract 3x, I'll have a quadratic, which I have to factor. X squared minus 3x minus 18 factors as x minus 3 times x plus 3. Find the zeros, and you get x is equal to 6 or negative 3. So, solution solved. Okay. Now, you could just as well check your work on decimals, and I'll just show you doing this once here. But really, when I have this equation here, I have a system of two equations. One equation is y is equal to x minus 18 over x, and the other equation is y is equal to 3. Okay, so I'm going to set those two equations equal to each other and then solve. So as you see, if I go out to decimals here, I have y is equal to x minus 18 over x. So that's the red graph there. We call that a hyperbola, but that's a rational equation. We'll look more at rational equations or functions tomorrow. And then I have the other equation, y is equal to 3. So I want to find where they intersect. And they intersect there at x is equal to negative 3 and x is equal to 6. See, negative 3 and 6. And those are the solutions I got, 6 and negative 3. So let's do some more of this. So again, I start with 10 over 3. I have 10 over 3. And then that equals 4 over x, and then plus 2, which I'll write as 2 over 1. So my LCD, it has to include the 3 and the x. So I'm going to multiply everything by my LCD, or 3x. Okay. And then we just divide it and multiply. So 3x divided by 3 is just x, and x times 10, well, that will give me 10x. And then 3x divided by x is 3, and then 3 times 4. 3 times 4 is going to give me 12. Again, you know, we're just distributing. We're distributing everything. And then finally, 3x divided by 1 is 3x times 2, and that will give me 6x. Okay. Subtract 6x from both sides, I get 4x equals 12. I get x is equal to 3. So let's look at the next one. So here everything is written as a fraction. My LCD, it has to include the x in the 4. So it has to include the x in the 4. So my LCD is going to be the 4x. So I'm going to multiply the entire equation by 4x and distribute each term. So 4x divided by x is 4, and 4 times 6 is 24. 4x divided by 4 is x, and x times 5 is 5x, and then 4x divided by 4 is 1, and then 1 times 7. Oh, 4x divided by 4 is x, and then x times 7 will, so that would be 7x, so I'll have a negative 7x there. And then I subtract 5x from both sides, I get x is equal to negative 2. Again, multiply by the LCD, get rid of the denominator. Let's look at the next one. Again, I have x, so I always like to write this as a fraction. X over 1 equals 6 over x minus 1 over 1. In my LCD, it has to include the x and the 1, so I'll multiply the entire equation by x. And then you divide it and multiply. So x divided by 1 is x times x gives me x squared. And then x divided by x is 1, and then 1 times 6 is 6. And then x divided by 1 is x. And then x times 1 will give me, so I'll have a negative x. Okay. And then let's see here, so then I'll subtract the 6 and add the x. Keep the x squared positive. We don't want to make that negative, so I'll subtract 6 and add the x, and I'll get x squared plus x minus 6. Which factors x minus 2 times x plus 3. So my zeros are 2 or negative 3. Final answer. Sometimes when we're solving these things, we get what's called an extraneous solution. It's a solution of an equation derived from the original equation that is not a solution of the original equation. When you solve a rational equation, it is possible. When you solve a rational equation, it is possible to get extraneous solutions. These values should always be eliminated from the solution set. Always check your solution by substituting them into the original equation. So again, let's say here I have equation 5x over x minus 2 equals 3x plus 4 over x minus 2. For all intents and purposes, when the denominator is the same like that, you could just ignore it. Because if I multiply by my LCD, that's just going to get rid of the denominator. So I'll have, when I multiply by my LCD, which is just x minus 2, that will get rid of the denominator. So I'll have 5x. I'll have 5x equals 3x plus 4. And you solve and you get x equals 2. But I want you to notice here, the solution is 2, but it's extraneous, because if x is 2, then what I'll have is 0 on the denominator. So 5x divided by 2 minus 2 is 5x divided by 0. And dividing by 0 is undefined. You can't divide by 0. Or if I had, so on the right side, I would have 3x plus 4 over 2 minus 2, which is this 3x plus 4 over 0. And again, dividing by 0 is undefined. So that's an extraneous solution. Okay, in fact, there is no solution to that equation there. There is none. There's no solution. Let's look at the next one here. Again, okay, so I have 2x minus 5 over x minus 8 plus x over 2 equals 11 over x minus 8. My LCD, it has to include the factor x minus 8, and then it has to include the factor 2. Okay, so 2x minus 5 over x minus 8 plus x over 2 equals 11 over x minus 8. My LCD, it has to include the 2 in the x minus 8. So when I take 2 times x minus 8 divided by x minus 8, well, that will leave me with 2 times 2x minus 5. That will leave me with 2 times 2x minus 5. When I take 2 times x minus 8 and divide that by 2, that will leave me with x minus 8. So I'll have x times x minus 8. And then when I take 2 times x minus 8 and I divide that by x minus 8, that will leave me with 2, so I'll have 11 times 2. Okay. And then we distribute the 2. So we have 2 times 2x minus 5 will give me 4x minus 10, plus x squared minus 8x equals 22. And then here, let me get rid of my keyboard because it keeps jumping up on me. So combine the like terms here then. So when I combine my like terms here, I'll get x squared minus 4x minus 32 equals 0. Factor, you get x minus 8 times x plus 4 equals 0. So x is equal to 8 or negative 4. Well, I have to go back to my original equation. I had 8 or negative 4. But if I go back to my original equation, I see if x is 8, then I'll have 0 in the denominator. So x can't equal 8. Otherwise, I'll have 0 in the denominator. 8 minus 8 is 0. So 8 is an extraneous solution, but negative 4 would work. Negative 4 would work. So sometimes you will get extraneous solutions there. Okay, so that's it with solving rational expressions. You want to multiply by the least common multiple or least common denominator to clear the denominator, and then you'll get a simple equation that you can solve, either factoring or just solving outright.